variables are binary stars. There's two stars orbiting around each other very closely, so closely that they're interacting very strongly with each other. In fact, one of the stars, its gravity is actually pulling material from the other star onto it. And when it falls onto this star, crashes onto it, all manner of X-rays and gamma rays, ultraviolet and visible light are produced. And there's a wealth of phenomena that result, and those are some of the things we're studying.
Now, you're talking about these two. Is this now where we're coming to the term cannibal stars and white dwarfs and things like that?
Yeah, exactly. These stars are very close together. They evolve from the stars more or less like our sun, but then they move closer and closer together as they lose energy. And when they get close enough, then the gravity is strong enough to pull the material over. And indeed, the kind of star that's doing the pulling is called a white dwarf. It's a star that's what our sun will become at the end of its life. Our sun will, in about 3.5 billion years, expand to engulf much of the solar system and then lose a lot of its material, collapse back down, and become a star that's as massive as almost as the sun is now, but only the size of the Earth. And that's an object we call a white dwarf. Very strong gravity around those kinds of objects, and when they would spiral in and come close to another star, very capable of pulling material off the other star with very energetic and exciting, interesting phenomena that result.
Just the one interesting thing that we picked up this morning, when you speak about these white dwarfs, you're speaking about matter, and you're speaking about matter with a very heavy mass. Somebody told me that a matchbox full from the surface of one of these would weigh 20 tons. Would you like to expand on that?
Yeah, maybe I can explain a little bit about that. The thing is that this white dwarf, which is a very compact star, is it really got the amount of matter it contains is similar to that in our sun, but it's actually compressed into a volume the size of the Earth. And that means its gravity is very high and its density is very high. And so the matchbox full would weigh literally about 20 tons if you took a material from that star.
But that doesn't really excite you because there are other aspects of these stars that excite your community.
It's really because the stars are interacting. I mean, our own sun is a single star. It's not a binary. We have planets around it. But there's many stars we know in the sky are binary systems, and these magnetic cataclysmic variables, as we call them, are extremely exotic systems in very close binaries, where you're getting all sorts of strange phenomena happening. Physics at extremely high gravities, extremely high energies, and also with magnetic fields thrown in, you are seeing very unusual effects.
When you say very unusual effects, are you talking replacements for things like nuclear physics and so on?
Well, you're getting, it's not so much that nuclear physics is going on these objects, but really the energies are so high that you're getting emission at things like X-ray wavelengths, which we can, of course, see with our own eyes. You need satellites orbiting the Earth to actually pick up these radiations. And in fact, it's recently that the number of objects in this field has actually just about doubled as a result of satellite orbiting the sky and picking up objects like these binary systems.
So you could use, for instance, let's speak about Hubble or one of those to pick up these.
Yes, this what you're seeing a picture now is of the what's called ROSAT, stands for Röntgen Satellite. It's actually an orbiting astronomical observatory which is designed to pick up X-rays from the universe. And this is the very satellite that actually detected double the number of these systems that are known.
Is there international collaboration on this? I mean, does South Africa play a big part?
Well, I'd like to speak to that. I think the fact that over 80 astronomers from around the world came here is really a sign, a recognition, not only of the world leadership that there are several astronomers here in South Africa have in this field, and I'd certainly name Brian Warner and David Buckley as two of them, but also the interest of the international astronomical community in supporting the efforts in astronomy here in South Africa. So astronomers here are definitely playing a leading role in this field as well as in some others.
You brought some more of those illustrations with you. Maybe we should take time out to look at those, and you could possibly just explain what they are showing us.
Yes, if we look at this one, this is giving you a good example of what an interacting binary might look like. You see on the upper right is this star that's about a similar size to the Sun, which is actually losing mass. And you can see it as sort of a bright white spot that's coming, and it's transferring mass into a disk that's on the lower left. And in the center of this disk is actually this white dwarf that we were talking about earlier, which is an extremely dense object. But the matter doesn't initially land on the white dwarf. It actually goes into an accretion disk. Now, possibly Don Lamb can explain about this picture.
Right. The picture that Bob was just telling us about was for a white dwarf with a strong but still a moderate magnetic field. We're finding objects that have magnetic fields that are millions of times greater than typically the Sun has, for example. And when the strength of those magnetic fields gets that high, it actually is capable of completely disrupting that disk of material and the flow in the disk. And then what happens is the material leaves the secondary star, as you can see there. It just forms a stream. And then where you see the stream increasing in size a bit, that's where it's interacting very strongly with the magnetic field. The magnetic field is beginning to thread it, capture it, and then funnels the flow right on down to the star without having gone through a disk at all. And that produces a light in the optical that's very highly polarized. As you probably have experience with polarized sunglasses, as you turn them, the light comes through one way or another. The same thing is happening with the optical light from these objects, very strongly polarized, and as well as a lot of light coming to us that's picked up by satellites in the ultraviolet and in X-rays.
And then just one final question, gentlemen. What would be the future for this? Will there be some application for this nuclear fission happening out there in space?
Well, that's interesting. That, I mean, there's a question of why do you do astronomy? It's research, clearly, and anyone who's interested in astronomy is really interested in the universe out there. So I think to say what applications are going to have in the future is very hard at the present stage, but you've got to remember way back in a century ago in England, a certain gentleman discovered a phenomenon called electricity, and he said this was research, and he couldn't understand whatever application this might have in the future. So who knows?
Well, I'd also like to just jump in there with another comment, and that is that we're finding in the United States, both through talking with people who are entering science and technology and also through research studies, that astronomy is perhaps the most accessible science of all of them, more accessible to young children than chemistry or physics. And when you talk to the people who've gone into science later on, you find very, very often that it was some experience in astronomy and finding out about something in the universe that first excited them and tweaked their interest and led them to go into science and technology. So I think science, astronomy has perhaps a special role among the sciences in bringing forth that excitement, that awe that leads young people to take up careers in science and technology, and I think is very important, certainly for South Africa and also for all countries, that we have these young people interested in doing this.
Well, I'm sure we interested a lot of people with what you told us about this morning. Thanks to Professor Don Lamb from the University of Chicago and Dr. Bob Stobie, the director of the South African Astronomical Observatory, for your contribution this morning.